Let's take a look at a quick example here. I want to evaluate y/ds over the surface where surface is defined by z equals x plus y squared. X goes from 0 to 1 and y goes from 0 to 2. So the first thing I want to do is put together my parameterization in terms of my vector function. This is z equals x plus y squared, so I'm going to think about parameterizing this in terms of x equals x, y equals y, and z equals, you guessed it, x plus y squared. So now, if I take the partial of r with respect to x, that is going to be, let's see, what is it? 1, 0, 1. And the partial with respect to y is going to be 0, 1, 2y. And now I can go ahead and find this cross product. But, well, let's go ahead and do it. Let's walk through this, and then I'm going to show you here a moment that this is not actually necessary. But it's kind of fun, so let's go ahead and go through it. Okay, so this is going to be 0 minus 1, so this is a negative 1i, minus, this is going to give me 2y, where am I? 2y minus 0, so just 2y j, plus k is going to be 1. So this will give me the vector negative 1, negative 2y, and 1. The magnitude of this thing, oops, actually, I kind of wrote that wrong. Now I'm going to do the magnitude. That's going to be square root of 1 squared plus 1 squared is 2. So this is 2 plus square this, 4y squared. Now notice here that z was equal to x plus y squared. So if I took a look at the partial of z with respect to x, that's 1. The partial of z with respect to y, that's 2y. And we showed earlier that that component that I need is actually simply equal to the square root of the partial of z with respect to x squared plus the partial of z with respect to y squared plus 1. So when I do that, I will have this. That's exactly what we're going to end up with. So when I'm parameterized in this form, I really don't need to go through all this cross product. I really just need to say, hey, what's z? Find the partial of z with respect to x, partial of z with respect to y, and then here we go. So it's much faster than necessarily messing around with all that cross product, although they both would get you to the same place. So the double integral over the surface of y ds is equal to the double integral of over the domain of y, which was parameterized as y, so it's staying y, times the square root of 2 plus 4y squared. And I'm going to go dx dy. And what was x? X 0 to 1 and y was 0 to 2. So I'm going to remove this. Go 0 to 1, 0 to 2. There are no x's here, so the antiderivative will be x times this. 0 to 1 is just going to give me this back. So there's really nothing to even mess with. I can simply say this is equal to the integral from 0 to 2 of y times the square root of 2 plus 4y squared dy, which is obviously a very easy integral to take. Do a quick u substitution, yada, yada, yada. And I'm not going to go through the detail of this because this is, like I said, very straightforward, simple integral. And just so you can compare your solution, what I got, I ended up with root 13 root 2 over 3.